So what we're going to be talking about is plotting inequalities. We're going to plot inequality with one variable. Today, what I want to get to is I want you guys to be able to plot just an inequality with one variable, and that's it. That's not going to be too deep. It's not going to be too much information, and this is just going to be the basic sort of stuff here. What I want to do now is, and this is the start of our new topic. Our new topic is inequalities and linear programming. So as I've told you already, it's very, very similar to linear graphs. So don't feel like you might think, oh no, sir, like trying to teach us like you're trying to teach us linear programming at the same time when we've got a test. It's like, how can I keep all this information in my brain? I personally think it's like these two things are quite similar. So because they're very, very similar, it's not like you're losing information. And worst case scenario, as I said, worst case scenario, which is we have to keep staying in lockdown, this information we'll do a test when we come back, but this information will still be useful for understanding it. So let's talk about that. So inequalities and linear programming. So firstly, we will be able to plot one variable. Now, oh, by the way, it's the reason that there was a video at the start, for some of you guys are like, why the heck do we have to watch this video? You don't have to watch the video. I always just have the video on while people are coming into the class. That's because it's lesson 42, which is what is the meaning of life. You can actually, if you it used to work, I'm not sure if you type in what is the meaning of life, the universe and everything, you type that in, it says, yeah, 42 is the correct answer. It's just is there any meaning behind it? No, not really. I personally think the meaning of life is to increase the amount of happiness in the world, but that's just me. You might have a different one, and different religions have different meanings of life, and you can still have a meaning of life even though you're an atheist. But yeah, let's talk about today's lesson. Let's get away from the philosophical to get into the nitty-gritty of mathematics, which is, I guess, a type of philosophy. Anyway, vocabulary. I'd like you to jot this down if you could. Inequality is a term used to describe the range of values that a variable can be. They use the symbols less than or equal to, more than, or more than or equal to. These are the four main symbols that we're going to be using. We're going to be replacing the equal sign. So now when we talk about like 3x equals y equals 3x, we're now going to say y is greater than 3x, meaning that there is a range of values that y can be. There are also other ways of describing these terms, which is using curly brackets. Might as well show you them here. You would do them like this. The curly brackets, negative infinity to x, or the other way is this one. So yeah. So here we go. So inequality is the term used to describe the range of values that a variable can be. It's just, but you can use these variables using less than or greater than symbols. You can also use these values using the circle and square brackets. Circle brackets means that it doesn't include the value. Square brackets means it does include the value. You obviously can't include infinity, so that's why there's always a circular bracket on negative or positive infinity. We're not going to really be using these square circle brackets. I'm just putting them up there in case you guys encounter them in the future, or if you see them, you go, oh, I know what that means. But just so you know, most of the time we're going to be doing less than or equal to. And that's going to replace the equal signs in a lot of our linear graph equations. You can swap the equal sign back in just to plot the graph, and you will be doing that later on. But at the moment, we're just going to stick to these basic ideas. We're going to change the slide in about 20 seconds from now, unless someone here desperately needs more time to copy this down. Or are we all good?
Sir?
Yes.
Can we copy what you wrote in red?
You can if you want. I'm mostly just showing students this, but it might be useful to you. So if you want to copy, add that to the side of your table, then that's something you can do as well.
Okay.
And because of that, I'll keep it up for about another 30 more seconds, just so that, you know, Tristan can quickly copy these down. The next thing we're going to work on after this is just going to quickly touch on a worded example. What would this look like if we were doing like a worded example of this question? Like, how do we deal with them? Just so that we can get a good idea of them. So let's have a look at a worded example now. So let's jump into this one here. This is not a worded example, but it's definitely, this is the classic thing that you give to, that I usually give to year 7s and 8s. And I have to admit, as basic as this idea is, I still use this idea to remember. So if you forget, the idea is the hungry alligator, which is the open side of the arrows, always eats the largest number. The other way you can remember it is that the arrow points at the smaller number. So if you say, if you've got x is less than 20, then that means that x is pointing to the smaller number. That means x is the smaller number. But I prefer just thinking about this as an alligator that is eating some large 20, whereas the x, whatever it is smaller. It's really basic, guys, but trust me, it has got me out of a fair few confusions in the middle of tests, so hopefully that helps you out. But we're going to do a worded example first. Can I get you to jot down this statement? And then if you want, you can start off by writing down the equation. If you or if you don't want to just wait, you can wait for me to actually answer it. Now, some people might be celebrating, unlikely because it's not a popular thing. It is a sort of popular thing, but not really a big thing, to celebrate Christmas in July. If it was Christmas in July, then today would be Boxing Day. Because Christmas was yesterday, Christmas in July. However, for those of you that don't celebrate Christmas in July, that means we are within 6 months of Christmas. I love Christmas. It's one of my favorite times of year. But we're not talking about Christmas, we're talking about maths. Let's do this. The tree is at least 2.3 meters tall. It will never fit through the door. How do we write this down? Well, the trick here is that the tree is at least. Firstly, let's talk about this. The tree is at least 2.3 meters tall. So that means the tree is more than 2.3 meters tall, or it's at least equal to 2.3 meters tall. So what we do is we say T is greater than 2.3 meters tall. We know that the tree is taller than 2.3, or you could say T is 2.3 is equal to or greater than. That's what that sign means. It means that it's either either the tree is 2.3 meters tall or it's more than 2.3 meters. Now, that's a fairly simple example here, and I know that that might not be the most complex one here of all examples, but it's just a quick one just so you know which way you're going. So how did I do this question? I said, well, the tree is at least. So you have to take a second just to figure out, does that mean the tree is bigger than the 2.3 or smaller than 2.3? Luckily for us, there is more context here. It's like it will never fit through the door. It's actually more context. It helps us know that the tree is large. The tree is bigger than 2.3. But you can just establish that from this sentence here is at least 2.3. That's enough information to be able to solve it. So that's just a quick little word example. You won't get many of these, but it's a good way to be able to say, right, I know how to change a word example into a written example. And the reason we need to know that is so that if we need to plot this type of information. So what I'm going to do now is I'm going to show you guys, well, how do we go about plotting this kind of information? How does this link to our linear graphs? Well, let's look at this. Representing linear equalities, representing linear inequalities. 5x plus 1 is greater than or equal to 16. So how do I represent this? Well, the first thing I need to do in order to represent this as on a line, I'd like you to start off by just writing down the term here at the top. Don't worry about the number line yet. We'll come to the number line in a second. Now, when okay, cool. Just double checking that I just yep. Okay, so when I solve a question like this, I can solve this question exactly the same way that I would solve a linear equation. First, I'm going to subtract 1 from each side. And if I subtract 1 from each side, that's going to cancel this. Now I can subtract 1 from each side because that's just going to make this 16 smaller. This plus 1, it just means it's always going to be at least, if I subtract 1, then I'm going to just remove 1 from this 16. So this is 5x plus 1 is greater than 16. So that means 5x has to be greater than 15. 5x has to be greater than or equal to 15. Because otherwise, 5x plus 1 can't be greater than or equal to 16. And I can divide both sides by 5. Which gives me x is greater than or equal to 3. Now, how do I represent that on a number line? Well, how I represent this on a number line is I need to draw a circle at 3. And then I need to draw an arrow upwards because it's greater than 3. So it can be 3, but it can also be 4, it could also be 5 or 6 or 7 or 8. So I'm going to draw an arrow like this. Now, there is only one more convention that we need to do. Because this includes the value, it includes 3, we are going to use a solid circle. If it didn't include the value, then we would use an open circle. And there is no upper bound, so that means I'm just going to draw an arrow going off to infinity. And that's how we can do it. So I want you guys to copy this slide down. You don't have to do all the way down to -10. You can just, if you're lazy, you can just go down to -6 and 6. That's all right. But I do want you to draw a picture like this, essentially. That's got an arrow pointing upwards. And I want you to also maybe write down this working out here, because that working out is relatively important, because you need to be able to recognize that you can just do your regular linear graphs solving problems with a question like this. There is only one thing we'll need to watch out for, but I'll let you know about that in a second. Okay, we're going to move on in about 25 seconds. If you haven't got this copy down yet, that's okay. This is some brand new stuff, so let me know if you guys are understanding this or if it's a bit like, what the heck? I'm going to move on. Yeah, let me have a quick look in the chat. Is anyone freaking out yet? Nope, not yet. Okay, cool. Keep me informed. So the next thing I'm going to do is we're going to do a double one. So we're going to do -3. -3 is less than 2x plus 1 is less than 7. Now, in a question like this, we do the same things that we were doing just before. But what we do is we do them to both sides. So we're going to subtract 1. And we're going to subtract 1 from here and from here. That's going to bring our new equation to be -4 is less than 2x is less than 6. And then all I need to do is I need to divide both sides by 2. I need to divide all 3 sides by 2 pretty much. So first I divide the -4 by 2, which gives me to -2. Then I need to divide the 2x by 2, that brings me to x. And then I need to divide the 6 by 2, which gives me a 3. So that gives me the final equation. -2 is less than x is less than 3. So that means the largest the value can be is let's put these in, 3 and -2. So the value must sit between 3 and -2. So I'm going to join these two in a line, but it can't equal 3 and it can't equal -2 because it doesn't say equals 2. So therefore I leave the circles open. And that's how I draw. Oopsies, I've messed this up a little bit. Sorry about that. There we go. So that means the answer could be any of these. Let's look at an example, actually. You know what? Let's do that. Let's let x equal -1. You don't have to do this. You don't have to copy this down either. I'm just showing you guys this. If I say let x equal -1, what I'll have is -3 is less than 2 times -1 plus 1 is less than 7. Let's check. -3 is less than 2 times -1 is -2 plus 1 is -1 is less than 7. Is -1 more than 3? Yes, it is. Is -1 less than 7? Yes, it is. So this actually works. Can I get someone to pick a number that this will not work for? Pick a number in chat, someone that this won't work for, and we'll test it to see if it doesn't work. 8 is the guess from James. Thank you, James, for participating. Let's try 8. So let x equal 8. So 8's over here, right? That's completely out of this range. So let's check to see if this works. -3 is less than 2 times 8 plus 1 is less than 7. -3 is 2 times 8 is 16 plus 1. -3 is less than 17 is less than 7. Well, let's check if this works. Is 17 more than -3? Yes, it is. Is 7 more than 17? No, it's not. 7 is not more than 17. This does not work. This is not in the domain. So just so that you guys can see this, normally teachers don't do this. They just go, right, cool, we've graphed it, we're job done. I just want to spend some time playing around with a couple of these just to check that they work and whether or not they don't work. So that's just to quickly to check how you might check a value to see if it makes sense or not. And if it doesn't make sense, it's not in the domain. Just like how if it does, if a point doesn't equal on the graph, then it's not on the line, that kind of thing. So that was a question. We did a question like this. If I give you, I'll talk about that later. I'm going to write down though that I want to talk about online. Now, next. So we, pardon me. Okay. So we haven't talked about this one here. So this is the one we're going to talk about now. So -3 is less than 1. Now, if we were, don't plot this yet, but I want to show you guys this first, okay? If I was to plot this, right, how would I represent this in 2 dimensions? So if I was looking at this straight up, I would say, well, -3, let's draw this, let's draw a circle at -3 so that we know it doesn't represent it. And then we'll do a circle at 1, and then we'll just draw a dotted line, a solid line connecting the two. Easy. So how does this change when you look at 2 dimensions? Well, it realistically doesn't change much. All you do is instead of using a solid, instead of using a circle at -3, you do a dotted line at -3. So you do a dotted line at -3. And you're also going to do a dotted line at 1. So I'm actually, and then to say, and then what you do is you shade, and write this down, you're going to shade the non-required region. And the last thing you want to add is something called a legend. So what I've done here is to show you that we can shade it in green, but what you guys would probably do in your books is this here. If you want to be super special, you guys can instead use like a highlighter or something, but essentially, as long as this area inside is unshaded, that's the main one. And so what the last part is, you need a legend. Now the legend usually says region required, and you've got this blank square here. The reason that we put this legend here, you can lose marks if you don't have a legend, especially if it says, like in the question, make a complete representation of something and you don't have a legend. But the main reason that a legend is good is that it shows the examiner, which is going to be in this case me, but next year could be anyone, some random teacher from Victoria, is it shows the examiner what it is that you are talking about. It says, this is the region that is important. And often you will see questions that says, this is the region required is the blank region. Now that's the way that we do things. Sometimes questions will say the region required is the shaded region. But as long as you have a legend, it'll make it easy for us to tell what, make it easy for everyone to see what it is that you're graphing and what is important. I think the book sometimes uses the shaded region to be the region required, but the reason that we do it like this is so that it's clear. I'm going to give you guys are going to need a little bit of time to copy this down because you're going to have to draw a Cartesian graph. I'm going to give you guys what maybe, and this is only, I'm going to give you guys about a minute to do this. If you haven't been working on it already, then you should be working on it now. Maybe a minute and a half. So I'll give you a little bit longer than that. What I will say while you guys are copying this down is this is something called, this is only measuring it in one dimension. So I know that it looks, oh, this is fancy, but ultimately the only letter that we're dealing with in this question is X. We only care about X. If we had -3 is less than X plus Y, then we'd be dealing with 2. And that's what we might talk about in tomorrow's lesson. Is what we would, how you would deal with if we had 2 letters, but we're not going to be dealing with that today. So yes, what's going on? How would you draw -3x is less than x is less than -1? You would do the same thing, except you would have the negative, the line would be at the -1 instead of at the instead of at +1. So Min's just asking in the chat, what would happen if this was -1? Well, then all that would mean is that you would have this line here, like that. So then you've said, wait, no, and then he swapped it around because he's trying to be weird. He said, well, what if you have this? I think it's, let me just check in chat. -3 is greater than x greater than 1. Okay, so then you've got -3 is greater than x is greater than 1. Can't be done. I can tell you that's impossible because ultimately, like, you should be able to break this down into multiple components. So you can break this down into 3 components. -3 is greater than x is greater than 1, and -3 is greater than 1. This one doesn't make sense. -3 is not greater than 1. That doesn't make sense. You can't plot that. That doesn't make sense. It's not logical. You can't have a number that's greater than -3 and a number, a number that's less than -3 and a number that's greater than 1 at the same time. Such numbers don't exist. Same way as well, you can also break down this equation here at the top. You can break that down into 3 equations. You can break it down to x is greater than -3. You can break it down to x is less than 1. And you can also break this down into -3 is less than 1. That makes sense. The other two, well, it depends. The other two depend on where you plot it. We're going to do one more graph, which is something a little bit easier. And then I want to show you guys just one last little trick that I forgot to show you guys at the start that I'm going to come back to. So something a little bit easier, something a little bit less challenging. Y is greater than or equal to 2. So what that means, and so I'm going to give you guys let's give you guys 45 seconds to draw a Cartesian graph. Doesn't have to be a pretty graph, just has to be a little graph. Doesn't have to even have numbers on it. I just want you to draw an X and a Y plane. And then what we'll do is we'll start sketching. All right, here we go. In this question, it says y is greater than 2. Okay, so how do we draw y is greater than 2? Because that's a little bit different to what the other ones. The other ones had 2 points. This just has 1 point, which actually makes it even easier. How do we do this? Well, what we do in this one is we say, well, where is 2? Y equals 2 is here. Now, because it says greater than or equal to, the first thing I'm going to do is I'm going to draw a solid line here. So we've got a solid line here at 2. Okay? Because y equals 2 and y is greater than 2. Oh, whoopsie, sorry. So that means that the part that we don't want, the part that we want to get rid of, is all the parts where y is not greater than 2, which is like here when y is 1, which is here when y is -1, which is here when y is -2. All of these sections here where y is -4, that's a section where y is not greater than or equal to 2. So I'm going to cross that section out. I'm going to do that like this. And then you should do a legend. Just write region required, and you're going to do a box like that, and there's nothing in the box to say this blank region is the region we care about. But because we've got a solid line here, just another emphasis, that means that this is in the region required. So is this. So is this. All those points are in the region required because they have y is greater than or equal to 2. And that's how you draw a graph of a linear inequality with one variable. Now, I skipped over one little fact at the start, which is just a fact that I don't think I always forget. I'm going to add this to the notes after today because it's just a quick little fact with algebra. And I'm going to explain that fact on the next slide. I'm going to give you guys probably another minute to do this. Are there any questions on this stuff here, how I've done this? Okay, so on the next slide, I'm going to show you one last trick, and that's something that I should put into the notes somewhere. I'm not sure where to do it, but I guess I should do a slide before we start to plot them on graphs. But yeah, the last thing I'm going to show you is this. Ignore this. We're going to do pardon me, a quick equation. The equation we're going to do is we're going to do this. We're going to say that 10 take away 2x is greater than 2. Now, You can solve these types of problems in a very similar way, but there's one trick. Okay, so the first thing we're going to do is we're going to subtract 10 from both sides. Okay, so if you subtract 10 from both sides, that's going to give you negative 2x is greater than negative 8. So far, hopefully that makes sense. Now we're going to divide both sides by 2. Which is going to give me negative x is greater than negative 4. Yep. Okay. The last step is a bit weird. I want you guys to pay attention. We're going to divide both
Wait,
sides.
sir.
Yeah.
Shouldn't you divide it by -2?
Yes. Yeah, you would, but and you're correct. But I'm actually taking a second here because I'm actually going to do that now.
Okay.
We're going to now, I guess you could think about this as dividing by -1 or multiplying by -1. It doesn't matter how you think about it, it's the same thing. We're going to divide both sides by -1. Now, you can do this in one step in the future, but I'm just showing you this now. That's going to cancel out this negative. It's also going to cancel out this negative, but it does one extra thing. When you multiply or divide by -1, it swaps. It swaps the inequality. So that will mean that your final answer is x is, and this time instead of greater than 4, x is now less than 4. Can you guys see in this one how the inequality swaps directions? Does that make sense? Now, when I first saw this, I was actually a bit confused and it actually created, but I think the best way to actually approach this is to then use an example. So this will mean that this will only work, right? This will only work if the x is less than 4. So let's choose a number less than 4. Let's choose one. Let x equal 3. 3 is less than 4. So that means if I go 10 minus 2 times 3, that should be greater than 2. 10 minus 2 times 3 is 6, is greater than 2. 10 take away 6 is 4. 4 is greater than 2. Everything works. Everyone's happy. So you have to swap the direction. If you don't, it doesn't make sense. So let's choose now. Let's make x equal 5. Let x equal 5. Now 5 is not less than 4. 5 is not less than 4. So that won't work in theory. So let's see what happens when we use something that doesn't work. 10 minus 2 times 5 is greater than 2. 10 minus 10 is greater than 2. 0 is greater than 2. 0 is not greater than 2. That doesn't make sense. So that's just a quick little thing about how we deal with negatives. Now, the reason we haven't had to worry about negatives is because none of our questions have involved negative x or negative 2x or negative 2y. But I'm showing you this here now just in case you ever encounter it. And that's why I decided to take a second before I divided by -1 because I didn't want to. Now, you guys can skip this step If you remember, if you divide by -2, then sure, you would turn that from -8 to 4, but you just got to remember you're going to swap the direction of the arrows. I'll give you guys a second to copy this down because I think this is actually important to copy down. You don't need to copy down the checks that we did in the bottom right, but I think you should copy everything else down. If you haven't copied this down already. Once you do that, I'm going to explain what we're going to do for the rest of the lesson, which is the next 40 minutes. But yeah,